Hi everyone, as a master's student in space science and engineering in UCL, today I'll be telling you about 3 myths that a lot of people believe when it comes to space science. And let's start with number one. Number one is a classic one, that is no gravity. And this is a myth because gravity does exist in space. If we take a ball, for example here, and then if we throw it at a certain speed, what's going to end up happening is that it will take off and then it will go in this trajectory, fall back down to Earth. Now, if we increase its speed further, it will travel in a further trajectory and then drop back to Earth. If we increase its velocity up to a certain value, what's going to end up happening is that it will get into orbit around Earth. And this is exactly what's happening to the International Space Station. Now, the International Space Station is acted upon by 2 forces here. And that's one that's pulling it this way and one that's pulling it back to Earth. And because they are equal, it manages to stay in a free fall state, and that causes it to stay in orbit around Earth. Now, this orbit does decay over long periods of time, which is why we often need orbital corrections in the International Space Station. And the second myth that I want to talk about today is time travel is impossible. Now, there's a Mexican physicist, Miguel Alcubierre, and he proposed a warp drive theory in which we can travel faster than light. Now, this shape here represents a bubble that is around a spacecraft in the middle. And then the theory states that the spacecraft in itself does not travel faster than light because it violates the laws of physics. However, the bubble around it can travel faster than light. And the way it works is that the warp drive engine uses material to compress the space-time in front of the warp drive engine, and then it expands what's behind it. And this allows the space-time fabric to propels the spacecraft to speeds that are faster than the speed of light. Now, there's one problem here. To be able to create an engine like that, we will need a negative density in terms of material. So for us to produce the stress tensor here for this particular shape, then we will need a density of less than 0, which is a material that we haven't discovered just yet. The last myth I want to talk about today is about radiation damage in space. So a lot of people believe that radiation occurs instantly to instruments, which is not always the case. A recent research from UCL, which collected data from over 6 years of operation in space, showed no significant degradation in Gaia spacecraft. And this was because of the manufacturing techniques that were included in this design to avoid the radiation damage in space, which appeared to be successful.